Hello everybody, welcome to the video, and this is the first video of a video series that I would be recording. And yeah, in this video the goal is to give you a simple guide without all the marketing stuff for OpenThread and some related technologies. And yeah, from my experience, I think sometimes it can be a bit difficult to get started with all this stuff because it's just covered in a lot of marketing stuff, and you end up reading just a lot of stuff that is not even useful. So I try to just make it as simple as possible for the people who are interested in implementing or just learning about these technologies. And yeah, so this just like I said, the plan is to create a video series, or maybe more than one video series for this stuff. And I would try to implement them in like kind of projects. So we would do yeah, small projects. The one like here is the list of the technologies that I would try to cover. So the first one, we would start with OpenThread, and this is the first video of this first series. And then we would go to Matter, which is yeah, also a new standard. It uses Matter, OpenThread. Then we would sometime in the future we would talk about Zephyr, which is in a real-time operating system specifically designed for IoT, and it makes implementing Matter and Thread devices very easy. And yeah, it's really, for me, it's really the operating system for Internet of Things. And once we are through all of them, then I have a project in mind for a smart home, DIY. A DIY smart home. So basically, we would develop all our devices ourselves using all the technologies that we have learned so far, and then maybe some yeah, create like some temperature sensors, humidity sensors, things like that. And we would explain it and yeah, develop as we go. Yeah, so about me, my name is Wakar Rashid, and I'm an embedded, or you can call it IoT software engineer. I call it IoT as well because embedded, mostly people think about writing firmware, C, C++, and I guess in IoT the range is a bit more broader than just writing firmware. So we are also in the IoT space. We are also talking about cloud and web technologies and things like that. So I guess it's a bit more broader, and I fall into that category. So I'm based out of Munich, Germany, and yeah, if you want to reach out to me or have a chat or whatever, yeah, you can reach out to me on LinkedIn. The link is, you can see on the screen, and I will also try to put it in the description. My interests are in, yeah, renewable energies, so like energy management systems and things like that, Internet of Things, blockchains, so crypto and things like that. I'm not an investor, but I like to know about the technological sides of blockchains and how they work, and I find them very exciting. And yeah, that's yeah, also a hobby of mine. I'm also into cycling, and yeah, enjoy riding my bicycle, and also interested in startups, and trying to build a startup of my own right now. And yeah, it's not going as fast as I would expect. I would hope, because yeah, with jobs and everything, you don't have enough time to spend on side projects like this. But yeah, maybe when there is time, then we can talk about the startup stuff as well. Yeah, feel free to reach out to me, or yeah, also here in the comments if you have questions or suggestions. So let's get started with OpenThread. And in this first video, I would try to cover just the historical aspects of it, so that it's a bit clearer that what thread is and what it is not. And yeah, here I have listed them in the technologies or the concepts here in the order which I think they appeared. And yeah, here I'm doing PDFs, but I guess this is the first video, so I hope it's fine enough, and then we can go and maybe have a look at these maybe in a bit more details. But the first one that I would want to talk about is IEEE 802.15.4. And if you try to look into thread or something, maybe you came across this. And it's a IEEE standard for wireless communication. Basically, it's not a new stuff. So it came. It started in 2003, and then they keep adding stuff into it and keep improving it. But the main idea is that it's a MAC or physical layer specification, and it is designed for low power personal area network, you can say. And yeah, low power personal area networks, or for now you can think of them as like something like Bluetooth or things like that. So maybe the range here in this specification is 10 meters specified, but I think you can also use them over some other frequencies like 800 megahertz or things like that, which has a bit longer range. But I think for us this is a bit out of scope for us, because it's the lower layers and we just use them. So for us that would be too much important, but just to know, it's good to know that Thread is using this specification. And if you know about Zigbee was using that as well. And this is only the MAC layer, so it allows you to send like yeah, packets from one device to another just on the same link layer, you can say, which devices which are directly connected. And yeah, I hope you know enough about the layering system of the OSI. If not, please let me know in the comments, and I would try to explain them, or you can have a look at it yourself as well. It's very basic stuff. Then this technology was around for a while, and people were trying to use it in different ways, different stuff. And then come along the 6LoWPAN. And 6LoWPAN was basically, it's the name of a working group from IETF, which is another body for making certifications and things like that. They created several RFCs. If you don't know what an RFC is, you can say it's kind of a specification, or yes, something like that. It's a document that describes how a technology or how a thing should work, a new technology or a thing should work. So, and it's mainly used in the IP world, so in the computer networks and this kind of stuff, or in computer science. You have a lot of things that are documented in RFCs, or first released via RFCs. And 6LoWPAN it was a working group. They created several RFCs, and the goal of this was that to enable IPv6 communication over this IEEE 802.15.4. So if you recall, I just told you that this IEEE 802.15.4 is the MAC layer and the physical layer, and then the upper layer is, so you have the the physical layer, link layer, and then network layer. And the network layer in IPv6 is IPv6, but what happens is that the IPv6 packets, the sizes are big, they are longer, and IEEE 802.15.4 was not able to transfer those bigger packets. So 6LoWPAN, what they came up with was some kind of compressions and fragmentations and things like that to allow the transmission of IPv6 packets over this MAC layer, MAC or physical layer, and that's what it does. And this, if you have a look at the Wikipedia entry page for 6LoWPAN, then I guess that's a really nice point to get more information about this. Then this was also around for a while, and then we reached the thread and OpenThread. And I guess thread and OpenThread is kind of, you can say they added a bit more stuff into 6LoWPAN. I'm not sure what was added, or they just kind of decided to specify, like, okay, these are the stuff that we would stick to, and they kind of started this thread group is kind of a group of different companies, so Google, Amazon, and Apple, and all these kind of bigger companies. They came together and they said, okay, this is the technologies that we are going to be using from now on and they called it Thread. And yeah, they're now basically doing certifications and stuff like that. And the goal is to have interoperability. So to have devices that can operate with each other, that can talk with each other, that use similar technologies. And because Thread uses 6LoWPAN, so Thread is IPv6 based, and this is a really useful thing for us in the IoT, because it allows us to have each sensor have a unique IPv6 address, and you can send packets to it directly from the clouds, or like you can send packets directly from the sensor to the cloud, and you don't have to worry about too many translations and all that kind of different stuff. It just uses very kind of transparent routers and stuff, so it makes the network infrastructure part really flexible. OpenThread is then the implementation from Google, and yeah, we will talk about this in the next video as well, a bit more in details what OpenThread is, but Thread is just the specification, and then Google did their own implementation of it, and it's open source, and they call it OpenThread. And these technologies are for like small range communication, and this is mesh network technology, so you can have mesh networks up to like 100 nodes or things like that. There are some upper limits, but I guess for now we don't want to talk about that too much. And then there is something new coming or happening now. It's Matter. There is a lot of marketing hype around it. Some companies are making devices for it as well, but it is basically Matter was an old project called, the previous name was Connected Home over IP. So this is something you can think of it as like they wanted to use Thread to be used in smart homes, and Thread is IP, and it also supports some other IP protocols like Wi-Fi or Ethernet, whatever that can work with IP would work with Matter. Matter is the layer one. Matter in OSI model, Matter is sitting above the IP layer, so it's or maybe you can say it's an application layer, so it's in the upper layer. Maybe yeah, transport layer is probably also lower than Matter, but we will get into that a bit more in details. But Matter is basically, you can think of it as like connected home over IP. So it is using IP, and then anything that can work on IP, including thread, Wi-Fi, things like that, it can use Matter. And Matter is designed for smart homes, and it enables you to have, like, you buy a device. Let's say you order a smart light from Amazon or whatever website that you prefer, and you come up, they send it to you, and then the local Matter that you have at your home, the Matter network, it has an app as well, a local working app, mobile app. You scan the QR code on the device, and that device basically automatically gets added to your home network and is visible on your screens or whatever you have. We would do that as well in coming videos. Um, and that is it for now. I hope this video was not too boring. It was a bit of monologue, but in the coming video we will start with OpenThread a bit more in detail, and yeah, start writing some, hopefully start writing some code. Let's see. Thank you very much for watching, and please let me know if there's anything I can improve, because this is just me getting started. And yeah, we'll see you again. Thank you. Bye.